In this Flightstream tutorial, we will be going over the setup and simulation of a simple rotor case. Here in our CCS file, we can see that we've defined multiple boundary conditions such that when we load in our CCS file, we do not need to manually set up our wake termination nodes or trailing edges. Navigating over to Flightstream, first we will import our CCS file. We're going to set a pitch angle of 10 degrees by rotating our mesh. With this done, we're going to move on to our solver setup. First, we'll toggle to unsteady, then we'll set our CDI boundaries, and then we'll define our time stepping iterations, which will be for hover at least 3 to 5 full rotations of our propeller, and a time increment that will set the rotation of the propeller for each time step to about 10 to 12 degrees. Then we're going to define our plots for thrust and torque, properly assigning our boundaries. Then we're going to set our viscous boundary layer Reynolds number modeling to turbulent for the size of our propeller, enable viscous coupling, and then apply airfoil flow separation to our propeller. Now we're going to set up our new rotary motion. We'll edit the motion, setting our RPM to be 588.5 rotations per minute, and we're going to enable slipstream wake stabilization with 3 blades because this is a 3-rotor setup and we are going to be working in hover. We use the slipstream wake stabilization for hover because it adds a small artificial induced velocity to help with the convergence of our thrust and torque. We're going to set our freestream velocity to be 0.5 for our hover condition and our reference velocity equal to our tip velocity. Then we'll initialize our simulation by setting our model to subsonic and selecting periodic for our symmetry condition with 3 blades. Then we'll select default for our termination X location and initialize. We're going to select our preferred color map and custom range. And now we're going to run our simulation. By navigating to the plot window, we can toggle to our unsteady solver plots that we set up beforehand for thrust and torque, and we can watch live as the results are calculated to see the convergence. We'll cut here to the end of the simulation to show the results. Now that we've arrived at the end of our simulation, we can toggle to plot settings and use this tool to plot the mean value of either our thrust or torque. For the range, we're going to specify a time iteration of 72 to 108, as those are the ending iterations for our second and third revolution. By selecting apply, we can view the mean value. That's all for today. Thanks for tuning in to another Flightstream tutorial.